Hello folks, this is the question of 2003 May-June paper 1 and the question number is 9. So it says that a ball is released from rest above a horizontal surface. So if we have a horizontal surface here, the ball is released from rest. From here it comes here. The graph shows the variation with time t of its velocity. So initially v equal to 0, v equal to 0, then v becomes here maximum, and then it bounces. Let us say we show this bounce like this, and several things happen here. So we have been given in this graph areas x. Area x is this much. So if we can't see this properly in the camera, we can say that this area and this area are equal, which are been named as x and y. It is so because we have to go for the region for this being equal. So we have to search for the region which says that whether the ball's acceleration is the same during upward and downward motion, whether the speed at which the ball leaves, and so on, for one impact, and so on. So what we need to know is as this goes on decreasing, let us say, what we can say is initially the velocity of the ball increases from 0 to max velocity. So this thing shows that increase in velocity, and this part shows the collision. So this is the from here to here, it comes to rest, and then starts a negative part, and this is the velocity, let us say the launching velocity after collision. From this part to this part, what happens is from here to here the thing compresses, from here to here it expands, and from here onwards it leaves the ground. So the velocity is now negative and high, not as high as previously, but it's negative and high, and because of that its velocity starts to decrease here, and it reaches somewhere here where the v again becomes 0. So this part shows the ascent of the body, in space. This part shows compression, and then relaxation. This compression, relaxation, and this part shows launching of the body. So it again comes to 0 velocity here. This again it shows the downfall like this. This shows the downfall. So when you compare this is also downfall, this is also downfall. Here the distance was large, so that's why it covers more area. Here the distance it fell was less, so it covers less area. And after collision here again this is the part of compression. It undergoes compression, then it undergoes relaxation or expansion. This part again it rises. So this shows the rise. So again rise. So at this it reaches here, then again fall. So this part shows the fall, and again compression, and so on. So it up to here, it shows, this event shows the graph up to here. So that means it has undergone multiple collisions. So here, as we can see here, the distance that it rises here and that it falls, they are equal. The distance that rises and falls are equal. One thing that becomes equal is, the other is, what you can say is, the launching velocity here, the velocity with which it bounces back, is equal to the velocity here. Or speed is equal, actually velocity is not. So let's go here, let's go for the choices. The ball's acceleration is the same during its upward and downward motion. The magnitude is same, but the acceleration is different because it's positive and negative. When it comes down it's positive, when it goes up it is negative. So the speed at which the ball leaves the surface after an impact is equal to the speed at which it returns to the surface for the next impact. So it says that this speed and this speed is equal for the next impact. But what happens is the area does not show the speed. The area of VT graph does not show the speed, and also even it doesn't show the acceleration. Next is again speed. Area does not show the speed, but what in choice number D says is the ball rises and falls to the same distance. Yes, the area of VT graph shows the displacement or the distance. So that's why choice number D should be the correct answer. All the others are incorrect and can be avoided. So choice number C, D. So D should be the correct answer.